Hello, happy people. This is Mr. Wilcox coming to you from my kitchen table. The last thing we're going to do in pre-calculus this year is we're going to use our derivatives to find equations of tangent lines. We did this at the end of the last chapter for limits when we used the definition of a limit for our derivative. Now we're actually going to use our derivative rules to do the same thing. So today we're going to be given an equation and a point, and we're going to find the equation of the line that is tangent to that curve at that point. All right, so I'm going to pause for a brief moment so you can pause the video, write this in your notebook, and you're ready, hit play again. So remember, the derivative of the given function represents the equation for all the slopes of tangent lines. And so in order to find the slope of our tangent line, we're just going to have to plug in a value of our point to get the slope at that exact point. And so that is what we're going to do today. Given a point, we are going to find the equation of our tangent line. So here are the steps we're going to use. I am again going to pause for a second so you can pause the video. And when you are ready, again, hit play. So our steps today to find our equation of tangent line. First, we're going to find the derivative. We're going to place the x value of the point into the derivative so we can find the slope of our line. And once we have a slope and a point. So we're going to write the equation of our tangent line in point-slope form. So I have a couple examples for you. Our first example is to find the tangent line to the function x squared plus 2x plus 1 at negative 3, 4. So the first thing we're going to do in order to find the equation of our tangent line is we're going to find our derivative. So our derivative, we're just going to use our power rule. So we're going to bring down our 2 and subtract 1 from our exponent. 2 minus 1 is 1, so we get 2x. And then our derivative of x is 1. 2 times 1 is 2. And plus 1 is, our derivative of 1 is 0. So our derivative of x squared plus 2x plus 1 is 2x plus 2. So to find our slope of our line, we're going to find our derivative at negative 3. So we're going to plug in negative 3 for our x value into our derivative. And so we're going to get negative 6 plus 2, which is negative 4. So now we have a slope. We have a point, which gives us an x and a y. So we can write our equation in point-slope form. So we have y minus 4 is going to be equal to our negative 4 times x minus our negative 3, or x plus 3. So that is the equation of our tangent line at 3, negative 4 to that function. All right, our last example is f of x equals the square root of 3x plus 1, and we want to know the equation of the tangent line at 1, 2. So the first thing I'm going to do is I'm going to rewrite our function, f of x, as a function to a power. So I'm going to have 3x plus 1 to the 1/2 power. So now we can use our chain rule to find the derivative of this function. So let's do that. So remember, our chain rule said to bring the power down out front, so and multiply. So we have 1/2 of 3x plus 1 and subtract 1 from the power, so negative 1/2. And then to multiply by the derivative inside our parentheses, so the derivative of 3x plus 1 is 3. So that derivative, if we simplify that up a little bit, is going to be 3 over 2 times 3x plus 1 to the 1/2 power, or the square root of 3x plus 1. Not really supposed to have a radical in the bottom though, so that's why I leave it as a power. So now if we want to find our slope, we're going to go ahead and find our derivative at 1. So if I plug in 1 into that equation, I'm going to get 3 over 2 times 3 times 1 plus 1 to the 1/2 power. So 3 times 1 is 3, 3 plus 1 is 4, and 4 to the 1/2 power means you take square root. Square root of 4 is 2. 2 times 2 on the bottom then is 4, and on top we're going to have 3. So our equation of our line then is going to be y minus our y coordinate, which is 2, equals our slope, which we found to be 3/4, times x minus our x coordinate, which is 1. So the equation of our tangent line there is y minus 2 equals 3/4 of x minus 1. So today you just have to find the derivative of the function, plug in the x coordinate into that derivative to find your slope. Then once you have your slope, write the equation of your line and point slope form. So I hope you are all happy, I hope you're all healthy, and I hope you all have a great day.